cosine of theta equals 1. That means cosine of theta is equal to 1/2, and I just want those two angles, fourth and first quadrant. Just cosines of 1/2. That would be plus or minus pi thirds. I've got my bounds of integration.
So where exactly did you get the 1/r cosine theta? Because I was still drawing the picture when you were...
That was the easy part. That just came from replacing x with r cosine theta.
Oh, okay.
Remember, it's a game of putting on a different pair of glasses. Everything is going to be written in terms of r's and thetas.
Okay, wait. So you just did algebra there and got theta equals the blah blah.
So are you here? Are you there?
Yeah, I was just saying you did some algebra in your head and that's how you got that.
Yeah, piece of cake. You guys, I'm really stalling because I was hoping to say, can I not finish? I don't know if I can say that because I guess I am just too tired. I can't see the front of my head. Let's take this a little bit further. If I were to evaluate this piece, I get negative pi thirds to pi thirds. Integrating here, if you integrate secant of theta, what do you get?
You're not going to integrate secant of
Thank
theta.
you. We're not integrating secant of theta. I'm integrating respect to r first. You guys see my point? So I think antidifferential respect to r is merely going to give me an r times the secant of theta. And I'm going to evaluate as r ranges from 1 plus cosine of theta to 3 cosine of theta. And then when I'm done, I'm going to integrate respect to theta. But I think that gives me the integral from negative pi thirds to pi thirds. Okay, I got to slow down, you guys. I've got everything divided by the cosine of theta. But what's upstairs is going to be a 2 cosine of theta minus 1.
Where'd the r come from? Because I thought we got rid of that r.
I did, but now I'm integrating respect to r.
Oh, okay.
And so integrating that constant respect to r is going to give me r times that constant. Do you know, you guys,
I'll just simplify that, though.
at this stage of the game, I think I don't want to finish the problem. Is that okay? Because now it's just obvious.
Yeah.
Take a mathematical ax, split up in two fractions. The first one's just 2. Integrate, I get 2 theta. Second one's going to be negative secant of theta. But the integral, or the antiderivative for negative secant of theta is
Natural log.
negative natural log of the absolute
Value of secant of theta plus tangent of theta.
Tangent of theta. And then you can evaluate all the garbage of those values of theta. Why isn't what? Well, it's this minus this. Matt?
Folks seem to focus on on being able to change your bounds. Can you do that in polar coordinates?
Oh, I suppose I can try to contrive some examples where I can. It's just typically you wouldn't because these polar graphs are typically given as r being equal to the function of theta.
Okay.
I mean, the outer one has r as expressed as a function of theta, and so does the inner one. So unlike maybe the examples in the previous section where, well, it's just a stuff garbage in the xy coordinate plane, it depended on whether or not you could integrate the piece in the integrand's position with respect to whatever the first variable integration was. And if you couldn't, that's when you change the order of integration.
So far we're just using double integrals to find the area between curves in multiple dimensions, so we don't have to do as much algebra.
Okay, but I hate to refer to this area. In this case, I can interpret this as volume.
Yeah, but the thing that we're actually looking at in this case is area.
No, I still think it's volume. I still think, numerically speaking, what I get here is really the volume underneath the graph of z being equal to 1 over x in the three-dimensional plane, three-dimensional space, over that region in the xy coordinate plane described by that shaded region over there. So I still think I got a cylinder-type thing with a non-flat top.
Area and volume are the same thing.
Well, the area and the volume are only the same thing if I was integrating under the surface z equals 1.
Yeah.
Which is not the case here. Which is not the case here.
Wait, does he have to be 0 though? So because z equals 1, you're still going up by 1.
Well, I know, but now you can interpret the volume as the area of the base times the vertical height, which is constantly equal to 1.
Oh.
So I think numerically, suppressing units, numerically, I think the area and the volume are the same values, numerically. All the units are different.
Okay.
That's why I was being goofy. I said, oh, you know, something I should have mentioned last time is I could use double integrals to evaluate areas of planar regions. It's just that in the integrand's position for the double integral, you'll have a 1.
In the integrand's position,
Yes.
double integral.
of the double integral, remember how I talked at the beginning of class? If that function is just a 1, then this may be interpreted as volume, or it may be interpreted as the area of that rectangular, or that region.
Yeah. Okay. Oh. As opposed to actually having function. Okay.
So if we have just a DA that's applied, we're always doing 1 unit out. I mean,
No, I stronger than that. I think no matter what the double integral represents, I have a dA in there, because I'm integrating the lower area.
and we're always assuming at this point for the volume.
No, quite the contrary. Look at this volume question. That was not looking up. I'm looking under a surface which is hyperbolic.
So that's my height.
Yes, that gives you your height above the xy coordinate plane. That's why I'm saying if the height is 1 everywhere, cheapers, I can interpret the volume as area numerically speaking, not in terms of conceptually. Well, do this. I want you to look at this region right here in the xy coordinate plane, call it R.
Right.
And I want you to go up 1 unit.
Right, I understand that.
I can use a double integral.
I understand that area and that volume. But now, have you changed the height being 1 unit yet?
And all my examples so far,
They're all
all
1
of
unit.
them, no, they're all non-1.
They're not 1.
Look at the integrand position.
Okay, that's
But
what
look
I'm
at mine,
saying.
it's not.
Okay, that's okay.
Even in my last example, it's not true. Remember how I drew the picture? We're looking at the volume of the cylinder, where the top was parabolic.
So this is throwing the height then, like if we had a box,
Yes.
so width times length
Times
times
height.
height.
It's just the height is not constant.
Right, okay.
So, like, the integral, is that you get the integral of 2 and then you get the integral of secant? So do we have to, like, have the integral of secant memorized because deriving it is kind of a pill?
You do not have to have the integral memorized, because deriving is not a pill, it's a piece of cake. It's just multiplied by funky looking formula 1.
But it's time on a test.
Yes.
Oh, the test is so short, don't worry about it.
Like,
It's like, what, I think maybe just 7 questions.
I think that would be the shortest test you do.
So 7 Balgai integrals though. That's there'll be derivatives and integrals in most of them
On this,
on this test. Yeah,
not the one
yeah,
on Friday.
there'll be chain rule, partials, integrals. Yeah.
Okay, guys, hold on. There's a really good question. In this example, could I integrate from 0 to Pythagoras and put a 2 out there? The answer is yes, because of symmetry with respect to the shaded region. Do you see it?
Not the picture, but.
Or do you see symmetry here with respect to the x-axis? Everybody.
No.
Everybody.
No.
No, that's not the reason. Well, it's true that I have to have symmetry for this region, about the x-axis. But it's also got to be true I have symmetry with respect to the surface. Do you see that? Because if I interpret that number down there as volume, then it's got to be the case that the surface has symmetry with respect to the x-axis as well. Does it? Does it?
I mean, like,
Yes, it is.
how do we know? I mean, if it's look over at.
What about 1 over x? What is z equals 1 over x look like? Oh. It's a hyperbolic surface. It just does this, doesn't it? Since there's no y, then I know that's symmetry. So it will work in this example.
So wait, we're talking about the symmetry from looking at it as if we're looking down from the z-axis, right?
Yes, yes,
Okay.
yes.
but there's only 7.
I feel like the fourth quadrant of 1 over x is different from the first.
Ah, it is, but I want you to look at this function in 3 space. Z being equal to 1 over x.
So I got you about, I just don't see how it translates to symmetry.
Then let's do this. Let me answer the question completely differently. You imagine the z-axis coming straight up here. And I want you to restrict your life into the xz coordinate plane. Don't you agree with this plane floating in the room? This curve looks like just this hyperbole right here. Now slide that in the y direction both ways to get the surfaces. You see no y's. I think it's a sheet metal, a piece of sheet metal going like this, smoothly coming up this way. Whereas it's saying no matter what the y value is going to be. Do you see it? And so since I get that cylinder moving along the y-axis, I got lucky in this example that I do have symmetry. I got lucky. That's why I was saying be careful. Don't just look at the symmetry of the bounded region in the xy coordinate plane. Look at the surface as well, if you're going to take those shortcuts.
So, only symmetry going this way, like, because of that way up and down.
Well, I'm saying, if you're gonna interpret this volume, you also have to have symmetry under the surface in free space. Because if this is gonna be interpreted as a volume value, then look at that three-dimensional object in three-dimensional space. You better have symmetry with respect to the top surface as well, in terms of the x-axis, I should say.
So you're saying the base could be the same, but then the z could be going like this?
Yes, and if it's all contorted like this, then certainly I can't split this up into the integral of 2 times the integral of 0 to pi-thirds, et cetera, et cetera. Do you see it? I'm nervous, I want more examples. May I? I want different types of examples.
Could we maybe take a look at this problem?
Well, I need to finish this. I'll try to make some time outside of class.
Okay.
Because I just don't like my repertoire questions. How about if I phrase it differently? Evaluate this interval.
Is that 2x minus x squared?
Yes, it is. Oh, yeah.
So we should start by subbing out rx squareds plus y squareds for r squared. Wouldn't it be, it'd be root r squared, right?
Yeah.
Sorry, I made a
So
mistake.
it'd just be r, yeah, okay.
No, they're.
Oh, no, because you have your r there too, so.
Well, I know,
yeah,
but I just want to
okay.
see, I want you to see. real
Okay,
quick.
yeah,
I can't do it, sorry. So sorry.
okay.
Oh, shoot, we're not done. What about the bounds? You moan.
So just plug in. You can't plug in stuff.
Well, I think we should just draw. Here's the x-axis. Here's the y-axis. And if I'm going to talk about the equation y being equal to square root of, I can't read it, you guys.
2x minus x squared.
Try to clean this up. What's that look like? The circle, whose center is that? Positive 1 to 0. Whose radius is? Positive 1. I think it looks like this. So I'm looking at the area underneath, actually just a semicircle, isn't it? It's only the positive square root. And then 0. This is region right here. There is a region over which I'm integrating. So you guys help me with this. If I draw in an arbitrary arrow passing through that region, emanating from the origin, what's the lower value of integration for r? 0. And what's the upper bound integration?
So, silly question, but you just completed the square there, right?
That's all.
That's, oh, okay.
Upper bound is. Well, see, I think when this arrow rotates from maybe 0 radians to pi halves, I think the tip of the arrow is changing position, changing length. The length of the arrow is changing completely. I feel so alone. Another name for x squared plus y squared is equals 2 times x, which is 2 times. Doesn't that imply r is equal to 2 cosine theta? Okay, I know I'm not supposed to divide both sides of the equation by something potentially 0. It's just that the arrow's only going to have length 0 units if I'm right there at the origin. And so I do think those r values in the circular region could be described by r being equal to 2 cosine of theta. And by the way, theta clearly ranges from, clearly, so clear. 0 to 5. Would you guys agree?
Yeah.
Wait, oh, you took the square root.
No, I didn't take the square root of both sides, I just divided both sides by r, making the assumption that r was non-zero.
Okay.
So,
Pi over 2?
Well, don't you agree spanning out the semicircle is done by having these red arrows range from 0 radians all the way up to positive pi half radians? Because I think it's just finishing up the pi half radians, I'm finishing up the small portion of the circle term. Anyone?
So can
No,
you,
I'm good, yeah, sorry.
can you basically, can you just show me the step from parametric to polar?
From here to here.
Yeah.
I did this. I said, if I got an x squared plus y squared being equal to 2x, then I get to replace this with my r squared.
Okay.
I get to replace the, excuse me, that's an x.
2 cosine of theta, or
R
2
times
r
cosine
cosine
of
of theta. All right.
Now, if we assume r is non-zero, I can write this.
Okay. Okay.
And you guys, I'm a little nervous by waving my hand saying assuming r is not equal to 0, but that was my lower bound of integration anyways, I'm not worried about it. So, you guys, I can't see it. Question. Is this going to be easy to integrate?
Yes.
Well, I get an r cubed. To integrate r cubed, I'll get an r to the fourth, but when I've added up bound of integration, I can be using cosine to the fourth.
Yes.
Oh, but there's a factor sign. Shoot, how am I going to do that?
Use of
Make a quick and easy use of. U is going to be equal to cosine of theta, and therefore d is going to be
sine of theta.
negative sine of theta d theta. Do you mind if I don't finish that one? That's the easy part, isn't it?
Yeah.
I think you'd rather me spend time in class looking at the challenging component.
Okay.
Do you have the answer just so we can try it ourselves? later?
No, I didn't. I don't answer my own questions. I just do them in class. In other words, when I'm at home making up examples, I just think about the integration techniques. Don't worry about the numbers. Well, let's see in 5 minutes. Can I generate another interesting question?
6 minutes. We're good.
Awesome. I think I can do it. You guys, it's just too easy. Let's do something different. Do you know what the volume of the sphere is? 4/3 pi r cubed. I'll use A instead so we don't confuse it with the variable r. 4/3 pi a cubed. So to actually come up with the volume, I guess I can draw myself a nifty little picture. X-axis, Y-axis, Z-axis. And if I've got at least a hemisphere, then I can think of this volume as being nothing more than the evaluation of a double interval, where the region D down below is a circle. And if the equation of the hemisphere is Z being equal to so A squared,
What's b squared?
I can't hear minus X squared minus Y squared. You guys that okay?
No.
Oh, you don't like that. Would you agree with this, Eric? That x squared plus y squared plus z squared being equal to a squared is indeed the equation of a sphere in free space.
Yes.
Now, if I algebraic this all for z, piece of cake.
Okay.
Oh, by the way, the equation, this boundary circle down below is
Squared plus y squared equals 1.
equals what? Yeah, I agree with you. I agree. And that being the case, to determine the volume of the sphere, let's you and I look at the evaluation of a double interval. And I think I'm looking at, well, the z values in my picture. If I were to draw an arrow, emanating from that region shaded in the xy coordinate plane up to the surface in free space, I think the high z value is given by the square root of a squared minus x squared minus y squared. And I'm just going to integrate over the area. Now I'll put in the details. I think another name for what's in the radicand's position is simply the square root of a squared minus r squared. Oh shoot, I forgot my identification of variables in integration. I guess it gives me an r dr d theta. also, my bounds of integration for R are gonna be from, and then from. So one full revolution. You know what, you guys, I'm rushing. I think I just made a mistake. I think everything you see on the board really does not represent the volume of the sphere. It only represents the volume of the hemisphere. My apologies. So to come up with the volume of the sphere, don't I need to, multiply by 2?
Isn't what you drew the hemisphere?
True, but I asked a question, which is, what's the volume of the sphere?
For the inner bounds of integration, 0 to A, where do you get that?
I get it from this. If you now just restrict your attention to the shaded region, the SY coordinate plane, draw an arrow emanating from the origin to the actual boundary curve, I think no matter where the arrow spins over that region, the SY coordinate plane, the outer R guy is always constant. That's the radius of the circle. And if I were to anti-differentiate, what trig sub is most appropriate here?
Why, don't use it, use a U
Yeah,
sub.
I think none of them are appropriate. Well, they are appropriate. I just think the
It would just make it
easiest thing to do here is
long,
to make quick and
yeah.
easy use of. Am I not really essentially integrating just the square root of U?
Basically, yeah.
And if I anti-differentiate root U, doesn't that give me?
But just 2U and you have the RU U.
Well, I think it gives me 2 times. I said 2. My apologies. I take that back. I meant anti-differentiate root U is simply going to give me U to the 3/2 times my 2/3. Oh, but shoot! Wait a minute.
Yeah,
If I allow
general.
U to be this, that means du is going to be negative 2R dr. I don't have the negative 2 in there, so I gotta compensate. Just make me use of my head.
I wish I could do that.
I know you can, and I'm going to actually evaluate R from 0 to A. Now I gotta confess, number 1, my 2's cancel here. Number 2, when I evaluate the upper bound of integration, don't I just simply get a 0? Do you mind if I don't write that? Minus this antiderivative evaluated 0, but when I'm subtracted, I cancel with the negative sign. And I think I merely come up with, can I steal the space? I think I merely come up with 2 times the integral from 0 to 2 pi of, I'm sorry, I've got to slow down. I don't know what I get. Is that going to be an A cubed over 3?
Wouldn't it be a 2 over 2? Oh, no, you're just gonna factor out that 2, okay. That's what you did.
Well, I cancel that. Okay.
No, I was saying it's 2A cubed over 3, but you can just factor out that 1/3 as well. So there's.
I did, you're right, I did, yeah, that's your point. And if I were to anti-differentiate with respect to theta, I just simply get a 1/3 A squared theta. And now when I plug 2 pi in for theta, doesn't it give me a, oh, thank goodness. What I should come up. So if you guys go to any parties tomorrow night, let me just show people this, they'll really get excited.
You can depend on how hard you do it.
This is why my wife doesn't take me anywhere anymore.
Just gonna ask, if you have just comparable constants, can you pull them outside of both integrals?
Absolutely. They pull out of both integrals, and it's just dealing with them every lump sum. Anybody else?
What's the normal equation for the volume of the sphere?
I just 4/3 pi cubed.
Oh, awesome.
I just used A instead of R because I didn't want to confuse with my variable.
Where'd your negative 1 go? Oh, never mind, I got
It's
it.
because I subtracted.
Yeah.
I found integration. You guys, I'm out of time. Do you think I could stop with not giving you homework? Can I just give it to you on Friday? You're probably not going to look at it anyway.
Okay.
Yes.
Can you tell us what sections
I'll say that, and I'll pull on the screen those exams. We can look at them if you want